Hello friends, in this lesson I will explain the structure and the working principle of capacitor without touching upon its types. Capacitor is a passive circuit element that is used to store electrical charges for a short time. It is formed by placing an insulating material between two metal materials. It is the indispensable circuit element of electricity and electronics. Today, capacitors are produced in different shapes, sizes, operating voltages and capacities, as you can see here. General purposes of capacitors are the process of storing short-term electricity, filtering in rectifier circuits and compensation. If we talk about the differences between the cell and battery and capacitor, we can say that while electrical energy is stored in the cell and the battery through chemical reaction, this energy is stored in a capacitor in the form of holding electrons in an electric field. Capacitors are ideal for use when we need too much energy in a short time. In cameras, flash is an example of capacitor storing the voltage and suddenly delivering it as high voltage. Capacitor circuit is indicated by the letter C. Its unit is farad. The capacity value is calculated by dividing the load amount by the voltage value. For example, if 1 volt and 1 coulomb of charge can be stored, this is equal to 1 farad. In other words, a capacitor that can store 6.25 times 10 to the power of 18 electrons with a voltage of 1 volt is worth 1 farad. In the same way, if 1 volt and 2 coulomb loads can be stored, this is equal to 2 farads. Farad unit is an enormous value. In capacitors, smaller values such as milli, micro and pico are generally used. Capacitors are examined in two groups as polar and nonpolar. There are positive and negative signs on the polarized capacitors. Therefore, the way it is connected to the circuit is important. The positive long pin must be connected to the direction of the current, while the negative short pin must be connected to the direction of the current. In case of reverse connection, the capacitor may explode and be damaged. Production capacity values can range from microfarad to farad values. These capacitors are preferred because the positive and negative direction of the current is important in the direct current circuits. Electrolytic capacitors are in this group. Their symbol in the circuit can be shown as follows. The way non-polarized capacitors are connected to the circuit is not that important. Production capacity values are mostly between picofarad and microfarad. These capacitors are preferred because the direction of the current constantly changes in the alternating current circuits. Ceramic and mica capacitors are included in this group. Their symbol in the circuit can be shown as follows. Capacitors have a capacity value and voltage values on them. Capacity value is the degree to which electrons are stored. So, it shows how much more electrons it can store. The voltage value indicates the maximum voltage value that it can withstand. For example, the capacitor on the left is a capacitor that can withstand 1000 microfarads and a voltage of 63 volts. The capacitor on the right is a capacitor that can withstand 1000 microfarads and a maximum voltage of 35 volts. Well, how is the structure of the capacitor? Let's take a look at it now. It contains an insulating material called dielectric. It consists of conductive metal plates placed on both sides of it. The dielectric material can be any insulating material such as ceramic, plastic, glass, mica and paper. If we think of it as a cylinder, we can also see that it consists of cylindrical insulator and conductive plates that surround it from the inside and outside. So, how does the capacitor's capacitance value change? The surface area of the conductor plates, the dielectric coefficient of the insulating material between the conductor plates and the distance between the plates change the capacitance value of the capacitor. The capacitance value of the capacitor is calculated by the formula you see here. Now let's summarize the working principle of the capacitor on a circuit. In the circuit on the left, the capacitor is connected to a 9 volts power source through a series resistor. Capacitor will be stored in this circuit. Its storage is expressed as charge. While the capacitor conducts current during the period until the capacitor is stored, it does not conduct current after storing 9 volts voltage. After the capacitor is stored, when we deactivate and connect it to the circuit with the resistor and LED on the right, the LED will light up. After the capacitor is discharged, the LED will turn off. Here, the charging and discharging time is very short. It happens in a very short time, such as 1/10, 100 or maybe 1000 of a second. It will be instantly charged and discharged. The total charging time is calculated by the formula you see here. The charging time is directly proportional to the capacitance value of the capacitor and the connected resistance value. In brief, this is the basic structure and working principle of the capacitor. I hope it's useful for you and you enjoy it. Hope to see you in our next lesson. Thank you and goodbye.